Uh, Good morning, children. Today we will come with a different concept about a pair of linear equations in two variables and how to find their common solutions. Yesterday we discussed what is meant by common solution of a pair of linear equations in two variables, and we have seen the graphical method of finding common solutions of a pair of linear equations in two variables yesterday, and today we will see how to find the common solution or solutions of a pair of linear equations in two variables by an algebraic method. The first method of algebraic method is substitution method. Okay. What is the meaning of substitution? Substitute means put someone in someone's place. For example, in place of x we can put y, or in place of y we can put or substitute x. Let us see one example of finding a common solution of a pair of linear equations in two variables by substitution method. Okay. See here. 2x plus 3y plus 5 is equal to 0 and 3x minus 2y minus 12 is equal to 0 make a pair of linear equations in two variables. Now let us find the common solution of these two equations. Common means if we find a solution for x and y and that values of x and y are put here, LHS should become equal to RHS, and for the same value of x and y, LHS should become equal to RHS in this equation also. Now I call this equation as 1 and I call this equation as 2. I keep equation 1 as it is, and in equation 2 what I do is I express y in terms of x, or I equate it for y. See here, I send this minus 2y this side, it becomes 3x minus 12 is equal to 2y, or 2y is equal to 3x minus 12. 2y is equal to 3x minus 12. 2 into y. If this into 2 is sent this side, it becomes y is equal to 3x minus 12 upon 2. I call this equation as 3. Now, I expressed y in terms of x. In equation 1, instead of y, I put y is equal to 3x minus 12 upon 2. Okay? This is substitution. I substitute equation 3 for y in equation 1. Okay? Y is equal to 3x minus 12 by 2. The same value of y in 2x plus 3y plus 5 is equal to 0. I will put. Now 2x plus 3. 2x plus 3, it is into y. Therefore into, where there is y, I put 3x minus 12 upon 2. Because y is equal to 3x minus 12 upon 2 here. Therefore I substitute the value of y is equal to 3x minus 12 upon 2 in equation 1 for y. Now it is 3 into 3x minus 12 upon 2 plus 5 is equal to 0. See here, the relation between 3 and this is multiplication. Therefore, 2x plus 3 into this is 3 into 3x minus 12 upon 2 plus 5 is equal to 0. Now, it is 2x, 3 3s are 9x, 3 12s are minus 6, minus 36. So, 9x minus 36 upon 2 plus 5. See here in the case of denominator there is 2. In place of denominator there is 2. Here these are without denominators and you have to add this. That is why you should have to take the LCM of 2 and 1, 1. See, 2x can be written as 2x by 1 and 5 can be written as 5 by 1. Now the LCM of 1, 2 and 1 I have to take. It is 2. Okay. Now you see, 2 2s are and 2 1s are, I'm sorry, 1 2s are, 2 1s are and 1 2s are. Now you see here, 2 2s are 4x, 1 into this is the same thing, 2 5s are 10, right? Now 4x plus 9x minus 36 plus 10 upon 2 is equal to 0, and 4x, when the things will come out of the bracket, there is plus sign, therefore the inner numbers will come as they are, they do not change the sign. Therefore plus 9x minus 36 plus 10 is equal to, this is divided by 2, divided by 2 is side, this side it becomes into 2, therefore 0 into 2 becomes 0, and 4x plus 9x is 13x, and minus 36 plus 10 is minus 26, therefore 13x is equal to 26, and now the relation between x and 13 is into, therefore into 13 comes this side becomes divided by 13, that time it is 26 by 13, 13 1s are, 13 2s are, thus x is equal to 2. Now I call this equation as 4, right? Now what I will do, I put x is equal to 2 in equation 3, where y is equal to 3x minus 12 upon 2. So now the equation 3 becomes y is equal to 3 into x, x means 2, because x is equal to 2 here, 3 into 2 minus 12, 3 2s are 6 minus 12 upon 2, plus 6 minus 12 is minus 6 upon 2, 2 1s are, 2 3s are, now it is minus 3 by 1, minus 3 by 1 is equal to minus 3, therefore y is equal to minus 3 is what? The equation 5. From equation 4 we know that x is equal to 2, and from equation 5 we know that y is equal to minus 3. Thus we became able to find the value of x and y, which are the variables of this equation and the variables of this equation. Thus the common solution of a pair of linear equations given here is 2 comma minus 3, that is the value of x is 2 and the value of y is minus 3. Thus 2 comma minus 3 forms one solution and the only one solution, which is called unique solution for this pair of linear equations in two variables. Okay, this is unique common solution, not unique solution, unique common solution for both these equations. If I put this 2 comma minus 3 for x and y here and here, here also LHS becomes equal to RHS for x is equal to 2 and minus 3, and here also LHS becomes equal to RHS for x is equal to 2 and y is equal to minus 3. Thus here 2 and minus 3 are such values of x and y which will satisfy both the equations, which will make LHS equal to RHS in this equation also and this equation also. This is how we will find the common solution for a given pair of linear equations in two variables by substitution method. Okay, what do we learn in this substitution method? The given equations are brought to standard form and they are called equation 1 and equation 2, and keep any one equation as it is, and another equation either you equate it for y or equate it for x. I have equated here for y. I put y is equal to this value in equation 1 for y. Then I find the value of x by transposition. Once if we find the value of x, that value of x is put the another equations converted in terms of y, or y converted in terms of x. And if I put the value of x here, after transposition I get one more value of y. This is how we find the common solution to a pair of linear equations in two variables. Okay children, here we will understand that if we plot the graphs are intersecting once. Okay, if the graphs intersect once, they will have only one common solution. If they have only one common solution, the graphs will intersect. And you also know that wherever there is a1 by a2 is not equal to b1 by b2, then also the graphs will intersect. And if the graphs intersects, there is only one common solution called unique solution. Okay, with this I conclude my session, and tomorrow I will come with the new method of finding the common solution to a pair of linear equations in two variables. Thank you very much. See you tomorrow. Goodbye.